Hey everyone, welcome back to DG Notion, where we break down the latest in digital technology. What if AI could think, learn, and react just like a human brain? Meet neuromorphic computing, a revolutionary technology that could change the way AI works, making it faster, smarter, and incredibly energy efficient. But how does it work? How is it different from today's AI? And could this be the future of computing? Let's dive in. 1. What is neuromorphic computing? Neuromorphic computing is a brain-inspired approach to AI. Instead of processing data step by step like a regular computer, it mimics the way neurons in our brain communicate, using tiny electrical pulses called spikes. Traditional AI relies on massive amounts of data and powerful GPUs to function. But neuromorphic AI? It processes information in real time with minimal energy, just like our brains do. 2. How does neuromorphic computing work? Okay, but how does it actually work? Neuromorphic computing is built on 3 key principles. Spiking neural networks, SNNs. Instead of binary code, AI neurons fire electrical spikes when needed. Event-driven processing. It reacts only when triggered. No wasted energy. Adaptive learning. It improves itself over time, just like a real brain. In simple terms, it's a brain on a chip. 3. Real-world applications. Neuromorphic computing isn't just theoretical. It's already transforming industries. Self-driving cars, faster decision-making while using less power. Healthcare and brain-computer interfaces. AI-powered prosthetics and brain-controlled devices. AI assistants in robotics. More natural, human-like interactions. Smart devices and edge AI. Phones and IoT devices that don't need cloud processing. This is just the beginning. Neuromorphic AI could redefine how we interact with technology. 4. Challenges and limitations. But of course, no technology is perfect. Neuromorphic computing still faces major challenges. Complex hardware. These chips are difficult and expensive to manufacture. Software compatibility. Most AI models today are built for traditional CPUs and GPUs. Scalability issues. Can we mass-produce these brain-inspired chips? The big question is, can tech giants solve these problems and make neuromorphic AI a mainstream reality? 5. The future of neuromorphic computing. Despite the challenges, major companies are already investing heavily in this tech. Take a look. With continued breakthroughs, neuromorphic computing could be the biggest leap in AI evolution. So, could neuromorphic AI become the key to building truly intelligent machines? What do you think? Will neuromorphic computing revolutionize AI? Or is it still too far away? Drop your thoughts in the comments. Make sure to like, share, and subscribe for more mind-blowing tech updates. See you in the next one.